Go.
All right, so right now we're around post mile 8 on Highway 1 in Monterey County. So we just crossed over the San Luis Obispo Monterey County line. We're inside the closure right now. That was at Salmon Creek, so this is like restricted area, so feel privileged to be here. I'm Joe Irwin. I'm the project manager that's helping out with the Mud Creek emergency opening project. Right now you can see just the toe of the work that's going on. And we're about a mile away from it, but we wanted to stay out of that area because there's a lot of trucks hauling rock, going back and forth. You saw them as we were driving up, those big 18-wheelers. So just to keep a big group of us out of the way, we're down here. But to give you some overview of what happened is back on May 20th of this year, we had a massive landslide. And I have a picture here that kind of describes what happened at the location. So this is an aerial view of the Mud Creek area. And in the past, what it was is this coastline was basically a straight line from here to there. And the mountain looked a lot like these mountains do right here. Where it just kind of went up to a point. But over the course of the winter, from December into May, we would have these smaller localized landslides where a little bit of material would come down onto the roadway. We'd clear that stuff off, and then a new small landslide would form, and we'd have to move those materials. And when I'm talking small, I'm talking in the neighborhood of like 10,000 yards or less. Okay, so it would be a full couple of days work of clearing the roadway off. So they'd get the roadway cleared, they'd come back in the morning, and there would be another pile of dirt that was even bigger on the roadway. Over the course of those few months, the landslides got bigger and bigger, and then in May, we decided that it was too dangerous to have the workers out there even, and we closed the highway off where they have all those the equipment right there on the roadway. And then on May 20th, which is a weekend, sometime between Saturday and Sunday morning, a massive event happened where 5.5 million cubic yards came down the hillside. So this right here is the area, and it's an anatomy of a slide. It kind of gives you a description of those things. We describe landslides in terms of like the human body. So this material right here is the landslide. That's what came from the scarp area and slid down into the ocean. So the top of it is called the head. Then you have the main body, which is the main portion of it. And then the bottom of the slide, what interacts with the ocean, is called the toe. So just like a human body. And to help us out, like to complete the analogy, we have these little armpits here that are on the side. Okay, so when this thing slid, we lost, like I said, 5.5 million cubic yards of material that came down the hill. We gained 16 acres of land, of new California coast land. The coastline extended out 550 feet away from the original coastline. And then it was the new measurement of that coastline was 2,200 feet. So that's just some numbers, just to throw out the scale.
2,200 linear feet.
2,200 linear feet measured along that toe. So if you look over here up on the slope, that is another landslide that happened back in 2011. That's alder, where the netting is, that chain link fencing kind of gray mesh that went up there, the unvegetated area. That's Alder Creek landslide. That one only had a few 100,000 yards of material. So you take that and you multiply it by 10, and then that's where you're getting to the amount of material that we had come down in the creek.
And how long did it take to clear / repair that one?
Well, that one took about 3 months of consistent, or 3 to 4 months of consistent digging and pushing. With this landslide, what we're doing is really driven, and we talked about this before at the PCH Blancas. We're driven by some pre-planning and some pre-work that we've done on the Big Sur Coast. In the past, back in 1983, so before, well, I was a year old, probably all of you were not born yet, so only a few of us were around. We had an even larger, or not larger, but almost as big of a landslide up at Macway Falls, or Pfeiffer Burns State Park, if you're familiar with that area. So there was a big landslide similar to this. Mountainside comes down, and we had just all this material that was sticking out into the ocean and covered our highway. What we did back in the 80s was we'd come through with a team of bulldozers, like 20 bulldozers, and we just started pushing the material into the ocean, just dumping as much as we could to get the highway back open. Because of that, and the work we've done with the coastal communities, with the resource agencies, we've become a more aware agency, and we're trying to take a different approach to landslide management. And we drafted up this thing called the Coast Highway Management Plan. And in that, it has different responses that we can do for landslides. How do we respond? How do we get the highway back open? One of those ways that we're doing here is relocating the highway. And so if you look at your packet that I handed out, I showed you a draft set of plans that we're actually working with, and this is from late October, so it's very fresh. This is the alignment of the highway that we're going to be doing over the main body of that landslide. And you might think, oh, that's totally crazy that you're going to be building a highway over a landslide. This is moving material.
That's totally crazy, Joe. You're going to be building a highway over a landslide?
Absolutely. I know what you're thinking. But the entire Big Sur Coast, from where we left at Piedras Blancas motel all the way up until you get into Big Sur and that, like the Esalen and the Macway Falls, all those places, and even farther north. All of that highway is built on ancient landslides.
What?
So,
are you kidding?
I'm not kidding. So we are just perpetuating what we've already done. But because we don't want to let the natural processes erode that area where we're going to build, erode this main body, we're taking some preventative measures. And part of that is building rock slope protection or massive 8-ton boulders, and we're lining that outside of the mean high tide line. So what we have going on here at this, where we are at Alder, is similar to what we're doing up in Mud Creek. We take these massive boulders and we stack them up in what we call a revetment, which is a flexible barrier made out of rock. And that prevents the wave run up from coming and eroding the soil away, which would then undermine the highway. So once we put this revetment in, it protects that highway. And if you want to take a look at some of the other photos that we got, you can kind of see the progress of the work that we've done up here. All right, so that first picture here, you want to get to this one. So this is about 2 months after the landslide occurred. We've built a network of roads across the main body, which again is relatively stable. It's not like your backyard, but it's not moving either. Okay, so it's stable enough that you can build this network of roadways. We put monitoring equipment, surveying devices, and geotechnical devices to measure how much the ground is settling, how much it's moving. And we built these roadways to access the bottom, the toe of the slope. And we started putting in these revetments. So you can see we're building this line of rock in one of those armpits to protect the embankments that we're building the highway up upon. So this is the next one here. You can see all the equipment. It's a very busy operation down there, which is why we're not taking.
And that's mostly imported material, or are you getting the rocks from nearby?
The rocks are imported from Cambria. We drove through there on the way up here, and then also some of it is coming from Piedras Blancas, or from the realignment that Paul had. Because they were looking for a way to get rid of it, our contractor was looking for rock, so they made a deal. So in this picture, the next one, you can see the revetment is in place, and we're starting to build the embankment above the revetment. That's what it's there to protect, is the embankment. If you look above that picture though, you can see a colorful line of storage containers. So what we did there is that is the top. That is the head of the slide up here. In a landslide event, you have this scarp area. That's the exposed part of the earth that slid away, right? That's that last piece of remaining soil or remaining dirt and rock up there. That is still active. That is throwing rocks out, but in a smaller scale than what the big landslide was. So it'll just be, I will say, a few rocks at a time, maybe a dozen or 20 rocks at a time, but these rocks are huge. They're bigger than these ones that we got stacked up here. So they're coming down, and those things can do a lot of damage. Once you have something that weighs a ton, that's rumbling and tumbling down a hill, it can take something out. So we put these storage containers up here, filled them with concrete barriers. So those
K-rails?
Exactly, K-rail, and that will protect the workers down below in case anything jumps and comes over the head. There's a natural valley that occurred here as the slide happened, behind the head, in between the scarp, and that's filling up with rock. So we're going to be building up this head, building this up with a berm, so that any more rocks that fall down this scarp or slide down the scarp get trapped in there. We'll come back for the next 20, 30 years with an excavator and clean that area out.
20, 30 years?
Yeah, this thing's going to be going for a long time. So geologic.
Maintenance, not construction, maintenance.
Yeah, it's
but
maintenance.
still, that's a long time.
I mean, when you talk about geologic timescales, you're talking eons for things to move and for mountains to form and things. And when they come down in an instant. But it doesn't just stop there. So they're going to continually be shedding rock. So this is the last picture, the most recent we have. So this is about 2 weeks old.
Wow, cool.
What ended up happening was at the ends of these revetments, so where the rock ends, the waves would come up and they would chew up the soil that was at the end of that revetment. So we have to start chasing that area of erosion and continuing the revetment. So when you look at those plans that I provided on that first slide, you'll see that the RSP is now going all the way across. That wasn't our original plan. We were just going to build the revetments in those armpits and think that everything else would stabilize. But as the erosion was occurring at a rate that was faster than we anticipated initially, we decided that we have to connect this with a revetment across the entire slide. So we're looking at something that's going to be around 2,200 feet or half a mile long of a flexible revetment along the toe of this slide. And the reason why we have to do it is on the final picture here. So this was taken in late October. I don't know if anybody is surfers or anything, but there was a big swell that came off of the Aleutians. There's a typhoon off of Japan that kind of hit at the same time. And we started getting a swell that was, I think, in the 20 to 30 foot range, which isn't even that big for this area. Like you can get 50-foot swells in like the peak. So these revetments were getting hammered. We had to think quickly and start working to try to extend it. And so you can see these excavators there just being dwarfed by the splash and the wave run-up that happens here.
What, that was October?
This is in October, yeah. So you were welcome to keep all of this stuff, but that's the slides. So after that slide happened, I talked about it extending out 550 feet. These, I only brought a few of these because there's a lot of them, but these kind of show you how fast we start losing material. When a landslide happens, typically it's loose, unconsolidated material on the outsides of it. So you can see these are some cross sections of the landslide. Sorry, go along the landslide there. So we'll pass these around and you can take a look at them. But you can see the rate of erosion that we lose. So there's a bluff here that starts being chewed up and starts eroding back. All of that sediment winds up.
What's the time scale?
Yeah, the time scale is May 27th, so that's a week after the first slide.
Okay.
Then this is about a week after, so 1 week.
Wow, okay.
This is another 2 weeks.
Okay.
This is 2 weeks after that. And then this right here, it's stabilized. So this is about, let's see, about 4 more months.
Okay.
So in the beginning, there was a lot of soil loss, right? So a lot of this loose, unconsolidated material starts flowing into the ocean. After a while, it stabilizes. But we didn't know when that point of stabilization would occur, so we had to come in and sort of lock in that toe of the slope. So that's why we're building.
So you just do it, and then you just keep monitoring. Then when you figure it out, then you start going to the next phase, kind of thing.
Yeah, it's an emergency project, so we have a plan in place that we're following, but everything you'll see is in draft form because things change on a daily basis. The weather patterns shift in a week, and we have to start thinking on our feet and figuring out what to do. The final thing I said is, I'll say on this project, Paul talked about having to work with resource agencies, and on a typical project, we work closely with them, but after we've written an environmental document, we'll go and obtain permits, and we'll go through a traditional permitting process where we make changes to our design to either mitigate or to avoid different species, and we'll do changes in the design process. With the emergency project like this, we are working under an emergency where we're supposed to get the highway open as fastly and as safe as possible. And so we get to go through an emergency permitting process. The Coastal Commission, the Army Corps, all of those regulatory agencies, they get informed of what we're doing and they get to provide feedback to us. But we work under an emergency notification process where we just say, this is what we need to do, this is why we need to do it. And then they tell us, okay, this is the mitigation you will have to do in the future, but get the roadway built right now. So there will be a follow-up process to all of the stuff that we're doing here, but it's not a mitigation that we have to do or technically an avoidance right of way. That being said, we do take some measures. That Coast Highway Management Plan I talked about, and the previous projects that where we would bulldoze all the material into the ocean, that's an avoidance measure of itself. Where we are putting the rock slope protection along the toe of this landslide, we're preventing more sediment from going into the ocean. We're preventing the loss of some habitat, black abalone, which is an endangered species. So we'll talk about that now because I think that's probably pretty interesting to the group here. So this area along the coast is very rocky and it's prime habitat for black abalone. When the landslide occurred, a lot of that habitat was lost. But on the edges...
Smothered,
yeah. It was smothered. And in the past, like Pfeiffer Burns, where we have these situations where we have massive landslides, we see that those areas take a long time to recover. So what we tried to do is we tried to prevent further sediment from going in. That's part of our process of locking it in with the rock slope protection along the toe. We're preventing further erosion going in, and so the resource agencies appreciated that. Another step that we took is along these pits here, these armpits, new beaches have formed. That sediment, once it goes into the ocean, it churns up, but then the waves wash it back up onto the beach. And so you have things that are much larger scale than these beaches here that are extending out now on either side of this landslide. Those will grow. They're dynamic situations because it's a new landslide, and beaches do always change, but they were growing. And so what we did was quickly partnered with those resource agencies to send them out with UC Santa Cruz, and they collected as many black abalones as they could save, put those into tanks, and then sent them down to Piedras Blancas where they could find some locations up along that stretch to relocate those black abalones. Other ones that were more damaged, they took all the way down to the Scripps Institute in La Jolla, and they're doing some research with those black abalones.
And some they outplanted, some they moved.
Yeah, some of them they moved from here down south to some more appropriate habitat that hadn't been silted over. But that sediment was spreading because it's still churning up. We're still losing some soil as we're trying to construct the revetment across the body. We still lose some soil during these big swell events. And so we didn't want to lose any more, so we tried to collect as much as we could and save the ones that were on the extremities of this landslide.
Yeah, and so our colleagues at UC Santa Cruz were telling me last weekend this was some of the best intertidal immediate rocky subtidal in all Big Sur. So this was a really hard place to lose habitat for these rare critters.
And so yeah, we're aware of that too, and so we're partnering with them. We're funding a lot of the study, and it's going to be a 5-year process of collecting the abalone and watching to see what happens, not only to where we relocated them to, but then what happens to the habitat in that kind of border area. We know what happened to the habitat around the slide. That's been covered in dirt. But the stuff on the extremities, on the sides, those are going to watch and monitor. So Santa Cruz is working with us. Monterey Bay National Marine Sanctuary is working. And it's been a really good process, actually. So I can't complain about it.
Cool.
Now, the plan with that roadway, that's contingent on us building that revetment and then building the embankments. Once we have those embankments up, really that's the major portion of this project, of getting the highway back open. But it's the end of November, it's closing in on the end of November, we're going to start getting some bigger storms, and you can't really work on a construction project or out moving dirt in a storm event. You got to let the soil drain out before you can go back and work in it. So we know we're going to experience some weather delays. We know that when rain happens, it can activate new landslides or it can make things unstable, so we have to let things dry out and settle out before we go and start working again. So our timeline for opening this thing up is going to be the end of next summer, which sounds like forever, but we will lose a lot of working days through this winter once the storms start hitting.
Yeah, and that being said, like, you might have to redesign your map too, because if like a bigger storm comes or something, then you have to like replan, I feel like.
Yeah.
Summer 2018 could actually be farther depending on how this winter goes, right?
Right. There were people that were concerned about releasing a date, but we're getting a lot of pressure from locals saying, well, what can you do? And this design, it allows for some flexibility to move the highway from one side or shift the highway a little bit. But we are confident that the main part of that landslide isn't moving. There's not going to be any more material that comes down. we're taking some stabilization into effect, meaning we're going to take some of the loose material that's still perched up on the slope, take that down and push it onto the main body of the slide. So we're using that material to build up these roadway embankments. So we're keeping it all balanced. All the material is going to be there. We're not putting it into the ocean, but we are aware that there is some slide material that still could come down if we didn't take action.
Cool.
Is it possible to like trigger a landslide so that like if you know that there's an area of high risk of landslide, can you trigger one just to get it over with? Or?
You know, not that big. It's not like we do that with avalanches. They'll shoot actual like M50 caliber bullets up there and destabilize landslide or avalanches. But no, we don't do that with the landslides. Triggering them. What we will do is there will be small, or I'll call them small in scale to the landslide, but boulders that look like they may come loose. Those are a real concern, the ones that'll come tumbling down. And so we'll send up blasting crews to dynamite those rocks out. So we'll clear the site, make sure everybody's out in a safe spot, and then we'll dynamite those.
Cool.
And because there's not any rock this size available in this area, you can see the truck that's leaving now, and then you'll see the truck going around there that's hauling it. We have to do this train of trucks to bring all of the material out. So it's a slow going process of being able to get the material on site, excavate out, put the material in, and then keep working and building as we go.
So it's you know, so we're talking about a year-ish to get this done. I mean,
Yeah.
I know it's hard to put numbers on this, but what's the scale of the cost of the project, roughly?
I'm gonna try to think back to what we've released publicly. $40 million, I believe, is what
That's all?
What we said it would cost. Moving earth isn't that expensive. Obviously, where we're at is hard to get to, but once you get the material on site or get the equipment on site, it isn't as expensive. But $40 million, I believe, is the target that we're shooting for.
Okay.
It's about how much, like a half a mile-ish or a little more, you said?
Yeah, half mile.
Okay, that makes sense then from, you said about 20 million.
That was 17 years, but yeah.
And so under an emergency project, what we're going through here is typically on a project, we will put a set of plans, a full, huge stack of plans out to bid to contractors. They'll respond with their lowest bid, and whoever bids the lowest gets the job. So we award to the lowest qualified bidder. On an emergency project like this, we don't go through that process. We choose our contractor, and it's usually the first person that can get out there with equipment to start doing the work. So we have John Madonna Construction, who was working on another project at the county line when this occurred, and we brought them on back in December when we started having those smaller slides. They came in with a few pieces of equipment and we're cleaning that up. Once it became a bigger project, then they just got to keep that, and we kept the contract going.
Cool.